Hello, welcome back. We will continue the revisionary series. Here I will take from question number 10. The expression for the electric field of an electromagnetic wave is given by. We know that E upon B equals to C. This clearly implies B equal to E upon C. Here, if we see B equals to E over C, divide this whole by C, and also we know that E cross B, this gives the direction of propagation. If E is in the J direction, then B can be in the direction of K or I. Here no option with I, all option with K, so J cross I. Direction of propagation is I unit vector. Okay. Question number 11. Here we have imagine an electromagnetic field in vacuum whose electric field is given by Ey equal to 0 and Ez equals to 0. What is the magnetic field associated with the wave? First of all, this is given as Ex. Then the magnetic field should be Ex. Magnetic field should be By or Bz. Exist. Then By. This is the By, and the amplitude is 10 to the power 2, but we have E over C equals to B. 10 to the power 2 divided by C, C into 10 ki 3 into 10 to the power 8. This will give the option D, but here the subscript is written wrongly. Therefore, the option should be By Z of T. This is only a trick. If you want to calculate, then go with the option is Ez is equals to A sine of A sine pi k x minus omega t. This is the general form. Question number 12. A harmonic electromagnetic wave in free space is described by E equal to E naught cos of kx minus omega t. What is the flux density? Flux density, the relation for the flux density is epsilon into C epsilon into E naught square divided by E. Hence, no correct option, no given correct option, none of the above. We have another question. Which are the following expression for a vector potential does not represent a uniform magnetic field? For this question, we have to calculate B equals to del cross A, and on expanding this you will get the answer. Which one of the following current densities can generate the magnetic vector potential? Also here we use B equals to del cross A. And using this value over here, we will get the answer. And the right answer is B. Non-conducting medium characterized by epsilon equal to epsilon naught and mu equal to mu naught and conductivity sigma equal to 0. The electric field, this is the value of electric field. This can be given as E is given as, we have to find H. Here the options are given. We have a relation B is equals to K cross E divided by omega. Also B equals to mu naught H. Then we have, and using B equals to mu naught H, we have H is equals to 1 over mu naught omega K cross E. Use this value of E, and using this value we will easily find H. 1 over mu naught omega, omega equals to, for omega we have, comparing this, E is equals to E naught sine of omega t minus kz. Then omega comes out to be 10 की power 8 and E naught is equals to 20. Therefore H is equals to 20 sine of 10 की power 10 की power 8 t minus kz into j unit vector k cross j unit vector as k cross E, then k cross j unit vector, and divided by omega mu naught omega equals to 10 की power 8 mu naught. Then k cross j equals to minus, then the correct option is option number C. Question number 16. No, I will not discuss further question because it will take time. Far away from any of the resonance frequency, the real part of the dielectric permittivity is. Directly learn it. It's a part that is always independent of frequency. The electric and magnetic field amplitude associated with an electromagnetic radiation. The correct option for this question is E is proportional to 1 over r square, B is proportional to 1 over r square. There is a relation for it. You can directly learn from here. We have a particle of charge q, mass m, and linear momentum p enters an electromagnetic field of vector potentially. For this we have to find the momentum, then kinetic energy. Kinetic energy is equal to p square over 2m. If we find the momentum, we will get p minus q over c a chi square. This is the momentum, p square over 2m plus 5. This is the right answer. Question number 25. An electromagnetic wave is propagating in free space. Then what is the b? B is equals to, we already know about it, b equals to E over c. Here E is over c, all are containing E over c, but E cos omega t minus kz. The option should be A or D, but E is in the I direction, then B should be in the J direction. This is the correct direction, and the direction of propagation is in the K direction. We have another question. This is the journal form for linear form. This is the linear form. Then question number 6. Directly learn from here. The right answer is k dot E equals to 0, k dot H equals to 0, k dot equal to minus mu omega, and k cross H equals to mu omega E. Question number 27. If read the question by yourself. The right option is K and S are anti-parallel. Here again we have a question. Question number 28. This question will take the pointing vector and then we will be able to solve it. It will take time. I will not be taking this question here for discussion. The correct option for this question is somehow 60. Do it by yourself. And there is another question, and it also very lengthy question. I will skip this for the moment. We have question number 30. Question number 30 is a direct consequence of Lorentz-Gauss equation. That equation is that del dot A equals to minus mu naught epsilon naught partial phi over partial t. If we compare, we get epsilon naught equals to 1 over 4 pi and partial phi over partial t equal to q over r square. Partial phi over partial t equals to q over r square. Partial phi over partial t equals to q divided by r square. Then continuing on this, from here partial phi equals to q over r square partial t. On integrating we get phi is equals to qt divided by r square, and the right option is qt divided by r square d watt. The vector potential in a region is given as A equals to something. The associated magnetic induction B is. For this also, write the vector potential A is equals to minus y I unit vector plus 2x j unit vector, and we have B equals to del cross A, and after solving we will get B equals to 3k. B option is the correct. And the next question is given wave and the propagation, direction of propagation, vector in the direction of propagation. Which of the following statement is true? K is complex. As you see, K vector is equal to z cap k cos phi plus iota k sin phi. Wave is this means wave is propagating in conducting medium. If K is complex, the wave is propagating in conducting medium. Thus, electric field gets attenuated as the wave propagates. And the most probable answer for this question is A part. Question number 33. Here given magnetic field. This is a very lengthy question. I will skip this also. The vector potential of an electromagnetic wave satisfy. You have to remember this question. This is important relation. Try to learn it. We have del 2a minus 1 over c square partial 2a over partial t2 equals to minus mu naught j. And this is the Lorentz gauge. Scalar potential of an electromagnetic wave. The right answer for this is option C. Which of the following can't represent an electromagnetic field in free space? Question number 36. For an electromagnetic wave in free space, we have k dot E equals to 0. And if you want to know what is k, this is the k. For example, for instance, in option number 1, k is equals to 2x k unit vector minus 4y z unit vector. This is the k. And what is the E? E is the E naught. For example, 2i plus 3j minus 4. This is for the option number A. Try this for all the options, and the correct option you will find B option does not satisfy this equation. Can the following scalar and vector potential described by an electromagnetic field? For an electromagnetic field, we have a relations del dot A equals to 0. Also del dot A plus partial phi over partial t equals to 0. Check for this. The dielectric constant of a material at optical frequency the correct option for the question number 34 8 is electronic polarizability. A parallel plate capacitor has plate area A separated by a distance d and contains dielectric permittivity epsilon. When a voltage V0 sin omega t is applied to its plate, the magnitude of displacement current JD and conduction current JC. This magnitude should be equal. JD should be equal to JC for this case. An electromagnetic wave, this is the clear-cut answer. E0 over B0 equals to C. And what is C? C equals to omega over K. Then which option is correct? Option number A is correct. When a monatomic gas is placed in a uniform field, the displacement of nucleus is proportional to, this is shear chart, E. The potential A and phi at the position defined by the vector R in magnetic field is, for the question number 42, the answer should be phi is the scalar product of E and R and the negative potential, and A is this question. Option number A is the correct option. The electromagnetic field equation in terms of A and phi. In terms of A and phi, electromagnetic field equation, this is the right answer. That is the del 2 phi plus partial over partial t del dot A equals to minus rho over epsilon. Question number 44. The right option for question number 44 is B. What? Here we have question number 45. The orientational polarizability per molecule in a polyatomic gas is. Directly learn this relation. This is the U square m over 3 kBt. A rectangular dielectric. Read the question. We have sigma equals to P vector dot N vector, which is equals to P naught K vector dot N vector. Sigma equal to P naught and the volume charge density rho equals to minus del dot P, which is equals to minus del dot P naught K, which comes out to be 0. The correct option for question number 46 is sigma equal to P naught and rho equals to 0. The vector potential is defined by, we already do a question like this. We already did a question. And that question is the, where it goes. Let it. Yes. Question number 42. And here A equals to 1 over 2 B cross R. The same answer is over here. A equals to 1 over 2 B cross R. is the vector potential. Then for question number 48 is a very lengthy question. In an electromagnetic wave, the phase difference between electric and magnetic field vectors E and B except in conducting medium. What is this? This is zero phase difference between E and B. For a given dielectric, the electronic polarizability is not affected by temperature change. We have question number 51. All the options are here. Look, see, option number D, electromagnetic wave are transverse in nature. Yes, it is correct. The field vector E and B are in same phase. Yes. Zero phase difference. The electromagnetic vector EB are mutually perpendicular and they are also perpendicular to the direction of propagation. Yes, it is also correct. The only incorrect option is C. Hence, the right option for this question is C. 52. Read this question. A monochromatic electromagnetic waves means that the field stand at a point varies with time according to the sine or cosine function. When a conducting sphere is placed in a uniform field, its polarizability is thrice directly. In a dielectric, the polarization is, I think it's a linear function of applied field. The oriental polarizability per molecule in a polyatomic gas is proportional to C. The direction of propagation of electromagnetic wave is given by, direction is given by E cross B. This is the E cross B. In a parallel beam of light density, you fall in an object totally reflecting the pressure exerted on the object is given by P equal to U over C. If the charge on a parallel plate capacitor is Q naught sine of omega t, then displacement is. For this question, we have to use JD, which is equals to partial D over partial T, and D, we know D equal to epsilon naught E partial E over partial T. E is given here, not E is given here, Q is given here. Then we also know E is equals to 1 over epsilon naught time. E is equals to 1 over epsilon naught time the charge Q. Use Q equal to Q naught. Then we have epsilon naught into upon epsilon naught into Q equals to Q naught sine of omega t partial over partial T of, look here, epsilon naught into partial over partial T of Q naught sine of omega t. Then we have 1 over epsilon cancel out. Then we have Q naught the derivative of sine of omega t is cos omega t into omega. The right answer is omega Q naught cos of omega t. Right answer is A. We have question number 60, velocity of a plane wave. Velocity is equals to V is equals to omega upon K. So here K is the beta. Then we have velocity equals to omega upon beta. This is question number 60. The right option is D option. We have question number 61. The frequency of the power wave associated with an electromagnetic wave having electric field. Again, we have the right answer is D. An electromagnetic wave is propagating in a dielectric medium of permittivity and permeability. The associated magnetic field vector H is. For the question number 62. First of all, this H is perpendicular to the E naught, and then after using the relation E naught over H naught equals to under root mu over epsilon. Here we got H naught equal to E naught under root mu over epsilon. The right option for this question is C part, perpendicular to E naught and this one. We have another question. The electric and magnetic field share the energy of the electromagnetic wave in the ratio. I think the right option should be 1:1. The electric vector and magnetic vector inside a conductor. Inside a conductor, it is never in phase. And then we have, in case of field of arbitrary moving charges, the magnetic field vector is such that directly learn this question. H equals to this one thing. This is the 2 GHz frequency and the conductivity is 25 Siemens. At this, the material act as the material for this conductivity value, the material act as conductor. Question number 61. I don't know much about this question. If n is a polarization vector and k is the direction of propagation of the electromagnetic wave, then we have clearly option number C over here. C n dot k equals to 0. This is the general equation. From an anisotropic dielectric medium, the relative permittivity is relative permittivity for the anisotropic dielectric medium is a tensor quantity. The Curie law. See it by yourself. 71. The wavelength of a wave. The wavelength of a wave is given with the propagation constant. Just see here, we have here k. We also know that lambda equals to 2 pi over k. Here the k is 0.2 pi k unit vector. We always have kx, kr, kz, and kj unit vector represents 0.2 pi is a k. 2 pi, then lambda equals to 2 pi divided by 0.2 pi. This cancel out and we will get the answer 10. Question number 72. This question is about the time average Poynting vector in Weber for a wave. This we know that Poynting vector S equals to 1 over mu naught E cross H. And this is a very tedious question. Do it by yourself. Question number 73. An electromagnetic wave has an electric field y direction. 73. Electric field in the y direction and magnetic field in the x direction, electric field in the y direction. Let's see. Electric field in the y direction. Let's see y direction. Then magnetic field in the x direction, Then we have y cross x, which is equals to minus k, minus z direction. The answer for the 73 is B what? Given E equals to something and free space B will be equals to E equals to, then B equals to we know that B equals to E over C and C is equals to omega over K. Here omega equal to omega and K equal to beta. Then C is equals to beta over K. Then B equals to beta is equal to K and K equal to beta. We have E equals to this one thing. We have B equals to E over C. Also C is equals to omega over K. Here K equals to beta, then C is equals to omega over beta. Then we have B equals to beta over omega into E. Then if E is in the direction of AY, then B is in the direction of B should be in the direction of AZ or AX. But if we see AX, AZ, then it should be positive. Consider here E in the direction of AY. The possible option for B should be AZ or AX. If AZ, then it is positive. If AX, then it should be negative, because E cross B gives the value of the wave propagation. This is the plane progressive in the forward direction from this equation. Then the right answer should be B. 75. I will not discuss more. Do the questions by yourself. I will tell you the answer. 76. Question number 76. The right option is let the time the wave represent a standing wave for the 76. No, it's not represent a standing wave. It's somewhat backward traveling wave. Do it by yourself. I have no idea about it. Question number 78. The unit of polarization P is polarization unit, same as that E per coulomb. Question number 79. 79 TDs. It requires a lot of labor. Do it by yourself. The amplitude of electric and magnetic fields are related to each other by the relation. And this is very clear-cut relation. E naught upon B naught equals to C. Then E naught equals to B naught C. Asked many times in the question paper. The energy of electromagnetic wave in vacuum is given by the relation. This is a very important relation. Previously asked many times. 82. Magnitude of electric displacement or electric induction depends on electric displacement मतलब D vector epsilon naught E plus P, applied field as well as dielectric. We have a relation D equals to epsilon E plus P. It depends on E, it depends on P. The right option is C. This relation is directly yaad. This relation is known as Clausius-Mosito relation. Question number 84. The orientational polarizability of a molecule is inversely proportional to the temperature, but decreases with increasing frequency. Option number B is correct. Question number 85. I have no idea about it. Question number 86. Where is 86? I don't know. Kidhar hai 86? The average flux of the electromagnetic energy over cycle for the electromagnetic wave. Eighty-seven. Again we have average flux. Flux is asked. 87. This is a clear relation. We know 1/2 epsilon naught E naught square cos square kx. This is the relation. Question number 88. Question number 89. In an electromagnetic wave in free space, we have the pointing direction is C part. Question number 91. 91 is the electric field inside a dielectric for disc shape. Question number 91. Electric field. We have question number 91. 91. Look it over here. Remind it over here. Question number 91. We have a relation E is equals to P over epsilon into 1 minus cos of theta. For a disc-shaped cavity, theta equal to pi over 2, and cos pi over 2 is equals to cos 90 0. Then E is equals to P over epsilon naught. See what is the right option. We have question number 92. Question number 92. This is very lengthy question. Just skip it. The right option for the 92, I don't know about it. It should be the electric field applied along the length of. Hey, what happened? Sorry. 92. It should be 0. I don't think. What is the option? What is the right option? Question number 93. The density of electrostatic energy in a dielectric medium is given by. This is a clear-cut C option. Question number 94. The electric field will be broken next with wave vector K. This is very interesting question, but it take some time. The right answer is, I don't know the right answer. Question number 95. Yes, the 95 question. This is very important question. Maxwell equation, we have del dot D equals to 0. Electromagnetic potentials, del dot D equals to rho. If in terms of E, then rho over epsilon naught, del dot E equals to rho over epsilon naught. Then we have divergence, del dot B, which is equals to 0, that is the monopole does not exist. Then third option is curl of H, which is equals to J plus partial D over partial T. And what is the curl of E? Minus partial B over partial T. On using these all relation, we get B equals to curl of A and E is equals to minus gradient. Just remember it directly. This is a very important question. This is important. Question number 96. The flux density is related to the electric field as, very easy. This is the epsilon E. Also we have B equal to mu H. If it asked for B equals to mu H. Asked for E is equals to epsilon E. D equal to epsilon E. Flux density. And question 98 and 99, question number 100. Then we have question number 101. This is also an important question. Question number 101. The right option is B. Question number 102. The ratio of E over B. E over B has the ratio of, has a dimension of resistance. The ratio of electric field vector and magnetic field vector B has the. Question number 103, question number 104. This is also an important question. The right option is question number 105, question number 106. The electronic polarizability of a monatomic gas is, this is the 4 pi epsilon naught r cube. Direct relation. Question number 107. Directly learn this equation. Question number 108. When a monatomic gas, the right answer is E. Question number 109. Question number 110. Thanks for watching the whole revisionary series on propagation of EMF wave. And in the coming days, I will try to take one more subject. Thanks for watching. If you like this, as also I am also doing the revision. If you can come across any mistake, kindly let me know. Question number 10. You can see vector potential, infinite silent wind and turns per unit length, radius r, and this one. Question number 10. This is a lengthy question. Let me solve it for you. We have integral A dot dl equals to A dot 2 pi r. For infinite solenoid with n turns per unit length, radius r, and current I, we have B dot ds equals to mu naught ni B dot ds. B dot ds is equals to mu naught time ni, and turns I current, and ds equals to pi r is square and the phi unit vector. And using the Stokes theorem we equate this to this. Then from here we got a equals to mu naught n I divided by 2 into r and phi vector. The right option is option number A. Thanks for watching. Thanks. Have a nice day. All the best for your exams.